Good day. In this lecture, we will discuss fossil fuels, focusing on their classification, formation, and role in energy production. By the end of this lecture, you should be able to classify fossil fuels and understand how they are formed and utilized. Fossil fuels are combustible geological deposits formed from decayed plants and animals over millions of years. They are primarily composed of carbon and hydrogen, which makes them excellent energy sources. Now, fossil fuels originate from organic materials buried under layers of sediment. Over time, exposure to heat and pressure transforms these materials into energy-rich compounds. A key intermediate is kerogen, which is a complex organic material. With increasing temperature and pressure, kerogen is converted into fossil fuels such as coal, oil, and natural gas. For the first type of fossil fuel, we have coal, which is a solid fossil fuel formed from land vegetation. Over millions of years, plant materials is compacted and heated, forming coal deposit. And coal is relatively abundant and widely used, especially in developing countries. Now, the next type of fossil fuel is natural gas. Natural gas is a gaseous fossil fuel that is cleaner compared to coal and oil. And it is mainly composed of methane, which has high hydrogen to carbon ratio. Like oil, natural gas is formed from marine microorganisms. It accumulates in underground reservoir and is extracted through drilling. Natural gas contains energy components such as methane, ethane, and propane, and non-energy components such as carbon dioxide and nitrogen. This composition affects its energy value and processing requirement. When natural gas contains additional hydrocarbons, it is called wet gas, and after removing this component, it becomes dry gas, which is primarily methane and ready for distribution. The last type of fossil fuel that we have is oil or crude oil, which is a liquid fossil fuel formed from marine microorganisms. Crude oil is the most widely used fossil fuel globally. Now, oil forms over millions of years and becomes trapped in rock formation. These reservoirs are accessed through drilling.
Dead plankton sinks to the ocean floor and gets deposited. The plankton is mixed with fine mud, clay. The resulting sediment made of the plankton, mud and anaerobic bacteria is now called sapropel. Sapropel is being buried by younger sediments, which increases the pressure and temperature of the sapropel layer. At about 50 degrees centigrade, corresponding to 1 to 2 kilometres of burial, the sapropel is converted into kerogen through anaerobic bacteria and chemical processes. The sediment layers may be folded as a result of tectonic movements in the basin. More sediments fall on top, increasing the pressure and temperature on the kerogen. At 80 to 120 degrees centigrade, or about 3 to 5 kilometres of burial, the conversion of kerogen into liquid petroleum occurs. The oil migrates out of the kerogen into sandstone reservoirs. These act as storage beds. Between 120 to 150 degrees centigrade, natural gas forms and also migrates from the kerogen into the sandstone reservoir. In some sedimentary basins, additional salty water might migrate into the sandstone reservoir and underlie the oil. An oil or gas field forms when the liquid or gas moves through the pores and spaces of permeable rock and collects within the pore spaces under an impermeable trap.
Fossil fuel contains various hydrocarbons which may also contain impurities such as sulfur, and these impurities influence fuel quality and environmental impact. The carbon content of fossil fuel varies. Higher carbon content generally leads to higher carbon dioxide emissions when burned, and this is a key factor in environmental considerations. Energy gained from fossil fuels is converted to electricity and heat in commercial power plants. When fossil fuels are burned, carbon and hydrogen react with oxygen in the air to form carbon dioxide and water. During this reaction, heat is being released, which further amplifies the reaction. In this case, this is an exothermic reaction, meaning that it releases heat. Electricity is generated by transforming mechanical energy into electrical energy using a turbine or generator. So the process is chemical energy going to thermal energy, going to mechanical energy, going to electrical energy. Now let's discuss coal-fired power plant. Coal is being burned to generate heat, which produces steam, which drives the turbines connected to the generators. This is one of the most common methods of large-scale electricity production. That concludes the lecture on fossil fuels. Focus on how these fuels are formed, classified, and converted into usable energy through combustion.